Hello, class. It's Mr. Mormon. Welcome to video 9 in my ecology series. Today we're going to talk about the role of climate in shaping ecosystems. As we saw in the biomes video, climate plays a very important role in determining what types of organisms can live in a certain area. The temperature and rainfall is going to dictate what kind of plants can grow, and the kind of plants and trees that grow will determine what kind of animals will live in that habitat. Some areas will be much drier. It might be a desert. Areas that have the proper temperature and lots of rainfall might become a rainforest. This idea would become very clear to you if you tried to grow something like bananas or coconuts or pineapples in your garden here in New York. Our climate is certainly not suitable for those tropical plants. By the same logic, if you tried to grow cranberries in the Rio Grande Valley of Texas, you would have very little success. It's way too hot and way too dry for this cold weather species. Actually, I should say cold climate species. It's important to understand the difference between weather and climate. Weather is the day-to-day condition of Earth's atmosphere at a particular time and place. The weather where you live may be clear and sunny one day, but cloudy and cold the next. Climate, on the other hand, refers to the average year-after-year conditions of temperature and precipitation in a particular region. Temperatures on Earth remain within a range suitable for life as we know it because the biosphere has a natural insulating blanket, the atmosphere. Carbon dioxide, methane, water vapor, and a few other atmospheric gases trap heat energy and maintain Earth's temperature range. These gases perform a function similar to that of the glass windows of a greenhouse. Just as the glass keeps the greenhouse plants warm, so these gases trap the heat energy of sunlight inside Earth's atmosphere. The natural situation in which heat is retained by this layer of greenhouse gases is called the greenhouse effect. This diagram illustrates the concept quite well. Here we see ultraviolet rays coming from the sun, UV rays. It passes through the glass of the greenhouse, and that light energy gets turned into heat energy. That heat energy is infrared. The infrared gets trapped, and you see the same thing happening here in the atmosphere. The heat energy gets trapped. Here again we see the same idea. The ultraviolet energy coming from the sun goes easily right through the atmosphere, but the infrared heat energy gets trapped. The main greenhouse gas is carbon dioxide, but there's others. Methane, water vapor are other examples of greenhouse gases which are trapping that heat energy. Because Earth is a sphere that is tilted on its axis, solar radiation strikes different parts of Earth's surface at an angle that varies throughout the year. In general, the sun's rays hit more directly at the equator than at the poles. This is going to make the equatorial regions much warmer because they're receiving much more intense and direct sunlight. This difference in heat distribution with latitude has important effects on Earth's climate zones. As a result of differences in latitude and thus the angle of heating, Earth has three main climate zones: polar, temperate, and tropical. The polar zones are cold areas where the sun's rays strike Earth at a very low angle. These zones are located in the areas around the north and south poles, between 66.5 degrees and 90 degrees north and south latitudes. The temperate zones sit between the polar zones and the tropics because temperate zones are more affected by the changing angle of the sun over the course of the year. The climate in these zones ranges from hot to cold depending on the season. The tropical zone, or tropics, is near the equator, between 23.5 degrees north and 23.5 degrees south latitudes. The tropics thus receive direct or nearly direct sunlight year-round, making the climate almost always warm. This diagram shows what I'm talking about. Here we see at the equator, these sun rays are hitting very directly and are concentrated in a smaller area, the same shaft of light here. is going to generate more heat. Here, that same light is spread out over a larger area, so it's going to be less intense. It's hitting at an angle. Here, it's 90 degrees to the surface. Here, it's a much less favorable angle, where you'll be receiving, much less intense sunlight and receiving less heat energy. What this does is creates zones of different temperatures. We would have polar zones at the north and south poles. Temperate would be in these latitudes. And of course, tropical in these latitudes. Of course, the tilt of Earth's axis is going to change where those direct rays are hitting. In the winter for the northern hemisphere, the axis is tilted away from the sun, and those direct rays are hitting more here in the southern hemisphere, making it summer in the southern hemisphere, winter in the northern hemisphere. 6 months later, the Earth will rotate to this position where the northern hemisphere is tilted towards the sun and receiving more of those direct rays, making it summer in the northern hemisphere and winter in the southern. This unequal heating of Earth's surface is what drives all global winds and also the ocean currents. One area being heated more than another leads to convection. Hot air rises, cool air comes to take its place. This gets the air moving. This also is what drives the movement of the water in the oceans. This simple diagram shows how convection works. The heat being applied in the middle here heats this water. It rises and gets replaced by cooler water from the sides. Again, hot air or hot water would be doing the same thing. The hot rises because it's less dense and it gets replaced by cold. Here we see the sun's rays heating the ground, hot air rising, cool air coming to take its place. These convection currents that get created are what create all of the global winds. It's what drives our weather and also ocean currents. And of course, these winds and ocean currents can have a great effect on the ecosystems that they are close to. Both temperature and precipitation will be affected by the local ocean currents or wind currents. The global winds, which are created by this convection and the unequal heating of Earth's surface, are then bent by the Coriolis effect. And the Coriolis effect will bend these large global circulations into 3 distinct bands in the northern hemisphere and the southern hemisphere. These global wind belts would be the polar easterlies at the north and south poles, the westerlies in the middle latitudes, north and south. That's what wind belt is over the United States. And then the trade winds. There's the northeast trade winds and the southeast trade winds, which are near the equator.
In this animation, we're going to look at global wind patterns and talk about the reasons why the air circulates the way it does, and also patterns of rising and sinking air and how that relates to precipitation. The engine that drives it all, I guess you could say, is the intense heating by the sun that occurs in the equator areas where the sun is shining at a very high angle of incidence. And this hot air near the equator, being less dense, rises upward. It rises upward and it moves toward the poles, and then it gradually sinks at about 30 degrees north and south latitude. So we create these big spinning circles of air that we call the Hadley cells. Now, near the equator where the air is rising, it loses its ability to hold moisture, and you get a band of high rainfall and low pressure because there's air leaving the equator. Where the air sinks, in these belts at around 30 degrees north and south, you get high pressure sinking air, which creates areas of clear skies and desert climates. Now, as this air circulates and tries to flow back toward the equator along the surface of the Earth, or as some of it heads toward the North Pole or toward the South Pole, the Coriolis effect, the spin of the Earth, causes it to bend and turn, and it's going to create the 2 big wind belts that prevail on our Earth, 2 out of 3, the trade winds, northeast trade winds and southeast trade winds, and then the prevailing westerlies. Now these winds curve in the way they do because of the Coriolis effect. The winds curve to the right of their path, north of the equator. They curve to the left of their path, south of the equator, and they end up flowing from east to west or from west to east. Now the other big factor is what's happening at the poles. At the poles, the air is cold, and the cold air wants to sink. And as that cold polar air sinks, it heads toward the equator, and it bumps into this air heading toward the pole here and toward the south pole here. And it creates an area of rising air, and again, rising air produces high precipitation belts at about 60 degrees north and about 60 degrees south latitude. At the poles themselves, the precipitation is quite modest because the air is sinking, and that creates low precipitation.
Okay, that's about it for this video. If you have any questions, as always, please bring them up in class tomorrow.